Everybody, this is your practice exam for chapter 2, number 2, for your trigonometry class. I'm just going to jump into it, and we'll start with number 1. Number 1 starts with a circle. I'm going to pretend like that's a circle. And we have a central angle. In my case, now keep in mind when you take your practice test, you're going to be using different numbers most likely than what I have. This is 96 degrees. And it says it has a radius of 5. And they want to know the arc length, this distance here. And if you remember, the formula is L equals R theta. Now, theta needs to be in radians. So we have to convert our theta into radians. And I'm going to get an exact value for this. For now, we'll have a decimal answer at the end, but so this is going to be 96 divided by 180. I'm going to show you a fancy trick here. If you want to convert that to a fraction on this type of calculator, you hit math and change it to a fraction. And it reduces it for you and everything. So that is 8 over 15. So this becomes 8 pi over 15. So using our formula here, R, which is 5, times 8 pi over 15. And that reduces to 8 pi over 3. Let's get a decimal approximation there. And I'm just going to take that number and go times pi. Oh, no, that's the wrong number. So 8 times pi divided by 3. So this is going to be 8.3775. For this particular problem, they don't have a unit, so you don't have to put inches or feet or whatever. But if there is a unit, you would, of course, would need to put that. All right, next up, number 2. We are looking for the sector area in this case. The circle with a central angle, in this case, of 105 degrees. Again, we're going to have to convert that. This is 105 degrees with a radius of 18 inches, it says. So now we do have a label that we'll need to do. So once again, I'm going to convert theta is 105 inches times pi over 180 inches, degrees, pardon me. And I'm gonna do that little trick again so I can keep a nice whole number for now. So 105 divided by 180, and then convert to a fraction. So 7 over 12 pi. Pi over 12. All right, our formula for sector area. So we're now looking for this area here in our unit at the end, because our radius is in inches, our final unit will be square inches. So the area of interest is going to be 1/2 r squared theta. This becomes 1/2 r is 18 squared times theta, which is our 7 pi over 12. So I'm going to get a little fancy here. I'm going to, instead of do 1/2, I'm going to use 0.5. It's the same thing. 0.5 times 18 squared times 7 times pi divided by 12. That gives us 296.8805 square inches. It's an area. And I should be boxing these final answers. You, of course, during this video should be verifying all of these numbers. Don't just take my word for it. For number 3, we have several questions being asked. So they say if theta is negative 11, let's start again. Theta is negative 11 pi over 6. They want us to find sine, cosine, tangent, and secant of theta. I'll get to that in a second. First of all, I have a negative angle here. So what I'm going to do to find its coterminal is I'm going to add 2 pi to that. Hopefully I'll get it between 0 and 2 pi. And getting a common denominator, I need to 12 over 6 here. This gives me pi over 6. Now this very nicely is going to let me use my special right triangles. Or you can use the unit circle. Both ways work. So first off, they want the exact value, which means you can't just dump it in your calculator. If you get a decimal approximation, you'll get marked off. We know sine is the opposite of the hypotenuse. So there's our first answer. Next up is cosine of pi over 6. We know cosine is the adjacent over the hypotenuse. So that is root 3 over 2. And secant, secant is one of them. I'm a little out of order, but that's okay. Is the reciprocal of cosine, or it's the hypotenuse over the adjacent, 2 over root 3. If you leave that unrational, if you don't rationalize that denominator, that's okay now. I guess that's kind of become a thing. And then tangent of 5 or 6. Using the triangle, tangent is the opposite over the adjacent. There you are. Now we are to graphs. And what I'm going to have to do is show you my other screen for this next one. So here's number 4. It says the graph above is a graph of what function? Well, it's definitely not tangent. I know this because tangent has asymptotes, right? And then those are more squiggly lines going up and down to infinity. So this is either sine or cosine. And how do I know the difference? I go to where it starts at 0. If it starts up, it's cosine. If it starts at 0, it's sine. It goes up like that. So in this case, this is definitely sine. Cosine. I just said that because we start up. All right, so now we're going to match the graph up to its function. If you recall, so this is either cosecant or secant, and so we have to figure out which one it is. If you recall, when your teacher does this in class, they actually draw in the curve so that you can find the asymptotes. And you can see this one starts up, so this is definitely a cosine curve here. And what's the reciprocal of cosine? That is secant. So this is definitely a secant graph. This one you can see starts here, it goes up and then down, just like a regular sine wave. So the reciprocal of a sine wave is cosecant. Now, how do we tell the difference between cotangent and tangent? Tangent has asymptotes at negative pi over 2 and pi over 2. So tangent can go through 0. So this one's definitely tangent, making this one cotangent. Because cotangent has asymptotes at 0, at pi, and so on. Cotangent. Yeah, that's how you do that. All right, so next up we have this one here, and I'm going to switch back screens so I can write this out. So here we are at question 6. Okay. All right, so we have y equals -7 cosine 1/7x. And the first thing they want to know is the amplitude. The amplitude is going to be this -7, but we just put the positive value. We don't care if it starts up or down on the graph. And so the amplitude in this case is just 7. And if you recall, period of cosine is 2 pi divided by b. B being the coefficient of x. So this period is going to be 2 pi divided by 1/7, which gives us 14 pi. So the period is 14 pi. And I'm going to get us a new sheet of paper now. All right, number 7. So we have the function y equals -9 cosine of x minus pi/6. And they want to know 3 things in this case. The first one is the amplitude. And remember, we just make that positive. It's just a +9. We don't put the negative in. The period. Once again, the period of cosine is 2 pi divided by b. Now, I want to point out the coefficient of x here is just a 1. So this period is going to be 2 pi divided by 1, which we just say is 2 pi. Last thing they want is the phase shift. In phase shift, it's the opposite sign that you see here. So the -6, it actually makes it a positive pi/6. So you always change the sign there. This one, we're going to make it positive no matter what. This one, it's always the opposite. All right, so for this next one, I'm going to switch screens. Number 8. Here we're given a graph, and we want to find what the equation of this graph is. First of all, I'm going to notice it doesn't start at any place normal. So it looks like this is the starting point if I were to start a period. You go to here. So it's looking to me that we have a midline that's not 0. Our midline is actually here at -1. Let's talk amplitude. So from here, the starting point, I'm going up 2, and I'm going down 2. That tells me that the amplitude is 2. Now we're going to talk period. It looks like the period goes from here to here. So it looks like the period is 4. And I can cheat a little bit. Take a look at the answer. So you don't get that feature. Let's move on to number 9. Which of the following graphs is correct? Is the correct plot of y equals 2 times sine of theta. So we have an amplitude of 2 and a regular 2 pi, which is about 6.2-ish. So it looks like all of these graphs are going from 0 to 2 pi. So we're good there. Now, a sine wave starts at 0. So it's either this one or it's this one. Oh, or this one. We just know it's not this one. This is definitely a cosine wave. Now we need to start here and go up 2, not down 1 or down 2. We need to go up 2 because that's a positive 2 there. So it's definitely going to be this graph here. All right, so we are actually coming up with the equation of this here. It looks like our midline is the x-axis, so we don't have to worry about +2 or -3 or something like that at the end. It's looking like it's a sine wave because I'm starting at 0, 0, so it's definitely going to be sine. Looks to me like the amplitude is 3, -3. And a period, it looks like a whole period is 6. So I go 0 to 6, even though we can't see it there. We can infer that. So I'm going to switch screens and kind of show you how to handle that. All right, this is number 10. As we discussed, the amplitude is 3, it looks like. Period is 6. So we know that with a sine wave, which is 6, in this case is 2 pi divided by b. And now I'm going to solve for b. I actually can swap the 6 and the b out. So this is our period. So let's go back to our problem here. And how would we write this out? Again, I don't have any vertical shifts. It looks like I don't really have a phase shift of any way. So we would type this in like this. So f of x equals 3 sine of pi over 3 x. That's the way that's looking to me. There it is. All right, here's another one. It's looking to me like the amplitude is at 4 and the period is 14. So I'm going to go 0 to, we know it's 14 because it hits -14 over here. So switching back just for a second. Oh, and also it's a sine wave because it starts at 0, 0. And so this is number 11. Again, the amplitude in this case was 4. The period is 14. So I'm going to do what I did up here. V equals 2 pi over 14, which is pi over 7. So going back to my problem, it looks like I'm going to be typing in 4 sine. Let's do a fraction. Pi over 7 x close. There it is. All right. What is the amplitude? We know that that's going to be 9. Let's see that there. 9. What is the period? Now, b in this case is 4. So 2 pi over 4 is pi over 2, which is what that is. Let me write that out so you can see it. All right, this is number 12. So again, the period for cosine is, so the period for cosine is going to be 2 pi divided by b. B in this case is 4. So it looks like the period in this case is pi over 2. And then switching back. What is the phase shift? I'm going to look right here. Remember, it's the opposite sign that's there. So the phase shift is going to be a negative pi over 6. And you can see it's negative there. And you can verify that if you take pi divided by 6, that you'll get this value. I prefer you put pi over 6 in. And we have another one. Amplitude in this case is 7. The period is going to be, because b is 2, 2 pi over 2 is just pi. You can see pi right there. The horizontal shift is 5. That's what that is right there. And this is going to be a shift to the right because it's a positive 5. Oh, I misread the problem. I'm sorry. The horizontal shift would be called the phase shift. I was mixing that up with the other. So the horizontal shift is right here. It's 8. Remember, it's the opposite sign. It's 8 units. Now, because it's minus, it's actually going to move to the right. I was supposed to select right. So even though it's negative and it seems like it should be going to the left, it's actually going to the opposite direction. That's why we changed the sign here. The midline, which is what I was mixing up here, is the plus 5. So y equals 5. There you have it. All right, it looks like we have a cosine wave here, and it looks like it's shifted down to y equals -1. Because from here, it goes up 2 and it goes down 2. So my midline here is at -1. So the end of my equation is going to be -1. The amplitude is 2, it looks like to me. And the period is 14 again. We had that from before. 14. Again, you may have different numbers and different graphs than what I have. So let me switch back and we'll try to put all this together. All right. So first of all, the amplitude, this is for number 14. The amplitude, in this case, was 2. The midline, we said it was at y equals -1. We have a period of 14, which is 2 pi over b. Swap those out. This becomes b equals pi over 7. So it doesn't look like there's a phase shift at all. So it's looking to me like we're going to have y equals 2 cosine pi over 7x minus 1. That's what it looks like to me. So let's switch back, see what we get. Yay. There it is. All right, so for this one, sinusoidal, that's just a fancy way of saying it's a sine shape, a sine wave shape. So a cosine wave would be sinusoidal. So the amplitude in this case is going to be 14. Remember, we dropped the negative. The period in this case is going to be 4 right here, 2 pi divided by 4. So that's going to be pi over 2. And the phase shift, let me write out the period again. I'm afraid someone's going to not be able to see what I'm doing. So remember, B is 4 in this case. So this is number 15. So the period is equal to 2 pi over B, which B in this case was 4. So that's going to reduce to pi over 2. And the phase shift, remember, is here. It's the opposite sign of what you see there. So it's going to be a positive pi over 6. All right, now tangent has a slightly different formula. All right, so this is number 16. So this is what we're given. I'm going to rewrite this slightly. So it's a little easier to see what B is and also the phase shift. Yeah. Okay. So for tangent period, is just pi over B. The reason it's 2 pi for a sine and cosine is because that's a normal period for a sine wave is 0 to 2 pi. Tangent goes from negative pi over 2 to pi over 2, which that total distance is the distance of pi only. Then it repeats itself. So in this case, B is 5. So this is going to be pi over 5 for the period in this case. Now the horizontal shift also known as the phase shift, is going to be, now the way that they word it, it's actually, we would say -6, but the way that they're doing this is they're saying that it's 6 units to the left in this case. I think it's easier to just say -6. That's fine. All right, we are now to the graphing phase. And we're going to graph just one period of this. This is y equals -3 sine of pi over 4 x minus 1. So we get quite a bit going on with this one. First of all, we need to remember that our amplitude is 3, but we're going to go downward first. Let's find our period. So period for sine, 2 pi over pi over 4 in this case. The pi's reduce out and we just get 8. Now I'm going to break it up into 4 pieces. So this graph, I'll go here. So 1, 2, 3, 1, 2, 3. And we're going to go to 1, 2, 3, 4, 5, 6, 7, 8. So we're going to break this up into 4 pieces. So 8 over 4 is 2. So we're going to go every 2. So my main markers are going to be, that's why, every second one. Now, these aren't necessarily points because we have to shift everything down 1. So I actually need 1 more. So I'm going to lightly draw in the -1. So this is my new normal line here because we're dropping it down 1. And so here are my important points. At 0, of course. And my 0 is down 1 because of the -1. Then I'm going to start by going down 3, and my markers are every 2. So I'm going to go 2 out from my next point. So I'm going to drop down to here. So every 2. Next up, I'm back to the line at 4. Then I go up here at 6. I'm going to be up to here. And then I'm back down to the line here. So there's my sine wave. There you have it. We have one more. Ooh, I have some room there. I can do that. So I'm trying to reuse some paper. All right. Our last one that we're going to graph is here. Oh, so we don't have a new midline for this one. So the amplitude's 5, and I'm going to start by going upward. Let's find the period. Is 2 pi over 1/4, which is going to give us 8 pi. And when I divide that up into 4 pieces, that means every 2 pi is how that's going to be labeled. So let's go ahead and of course, you get to do all this with a computer, so everything kind of snaps to grid. I'm doing this kind of old school. And so this means I'm going to go every 2 pi. And I'm going to go up and down 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So my main points are going to be here. I get to go up this time instead of downward like I did on the previous one. And back down here, and then there. There you have it. I hope this helps, and I hope that you do really well on your test.